Professor Bo, welcome to DEALITT podcast, where we like to invite CEO and head of companies and professional people like you. Professor Bo, you are really high experience. This is why we are really would like to welcome you in this podcast. Professor Bo, how are you doing today?
I am fine. Likewise, thank you very much, Dr. Khalid, for inviting me for this podcast. I believe which is especially casted for the geotechnical engineering community. I believe so. Yeah. Actually, as I mentioned before, I'm starting from this year. I'm kind of semi-retire. However, I'm still very busy with my semi-retire work and my small consulting company, and then also various duties in the few university in Canada, and then also assisting editing work for the few scientific and engineering journal, where I'm an editor. Also, I'm also preparing my another next textbook. And then also editing, some upcoming special issue for the journals and for that. I'm still busy. And then also I'm also serving in a few professional society as a committee member. So although semi-retire, I'm still busy.
Great.
Yeah.
I hopefully it will be very, very peaceful retirement. Although we really need you in the industry, Professor. Just I would like to give an introduction about your great experience, Professor. You do have a 45 of outstanding experience in geology, hydrogeology, and observational method, and different type of discipline. And also you do have very extensive experience in this geology and hydrogeology and observation method and civil engineering in general. And Professor, now you are the president of a company called Boo Consultancy. It's mainly specialized in geotechnical engineering. This is a small consultancy, but before that you have run a company called DST Consultancy. This consultancy is a medium consultancy. It's a geotechnical consultancy. At the same time, before that, you have worked as a geotechnical director in one of the largest and top company in the world called AECOM. And Professor, you do have a really long career in one of the top university around the world, and you really left a huge, outstanding effort in research, and you work as an adjunct professor in research and also in teaching. There are many of your students, they become professor and head of department now. You're really an amazing professor, I would say. Professor, how do you feel after this great career and great achievements? You're really one of the best, to be honest, geotechnical engineers.
Yeah, thanks for introduction, Dr. Khalid. Yeah, very, very comprehensive. You summarized my career.
No, it's not comprehensive. It's just very short, to be honest.
Yeah,
we can't comprehensive everything. You really did a good career, honestly.
Thank you. As a originally geologist, also as well as a civil engineer, I enjoy practicing in the industry as a consultant, as well as doing research in collaboration with the few tertiary institutions, especially to keep in touch with the advancement and also to contribute to the industry and to train and mentor the young generation, basically. As you know, to be a good consultant, you need to be ahead of the others engineers. And then also you need to be well innovated so that you can provide the, or services to the industry and then produce an end product infrastructure, which are not only cost effective, but also safe and long lasting, And then nowadays, more importantly, environmentally friendly. So that kind of infrastructure you need to produce. At the same time, I also managed to train next generation researchers, academics, engineers, and scientists through my research projects, which I collaborated with many universities, and then which leads to deliver many doctorate holder and also well-trained practicing engineers and scientists around the world.
Yeah.
Basically through a lot of interesting projects around the world.
It's a very interesting project, I believe so.
Yeah. I also have delivered many PhD students. Some of them already became a full professor. They are also become quite productive in the research, and also mentor and deliver many engineers and scientists. Nowadays, many of them very successfully leading the industry as some of them managing director, general manager, directors, head of the departments around the world in UK, Australia, United States, and Canada. They are doing well. I'm happy with them. Also happy with what I have done for them.
Yeah. It's really great achievement, to be honest, Professor. Yeah.
On the other hand, also, by using my research output and experience I gained through all the interesting project from the professional practice, I have been contributing to the industry by publishing, some books, textbook, and then also many technical papers in the engineering and scientific journal.
Yeah.
Actually, I would say I'm lucky enough to have such opportunity to be able to practice in both academics and industry and contribute to the both community, and also able to train and mentor the young generation. I'm happy with my career and then what I managed to do for the young generation.
Yeah, this is really, I think anyone learn from you, he will be lucky, Professor. Professor, I would like to dive into questions with you, but I would like to ask a question. I ask it to many people. It's about time management. Professor, time is very important, and you know that more than anyone. So how do you manage your time? How do you structure your time? I think it's worth to learn from you about that, if I can ask you this question.
Before answering, how I manage my time. Yes, I agree. Time is important, but I would explain some about managing the time by the other people or myself and all that. Yeah, all the time is important, but everybody have 24 hours. They have the same 24 hours a day, and nobody has more or less, unless people sleep too much or, otherwise they have, same 24 hours. But some people, they only manage to complete the limited text within a day. But others, they can complete many, many texts within a day. That is actually things to do with the efficiency and productivity. So some people, they are born with the efficiency and productivity, came from the genes. Many needs to be trained to be efficient and productive. Unfortunately, a few of the people, they were not able to receive the training, and also they may not be able to train to become efficient and productive. If you look at it either in your employee or, among your students who you recruited.
Yeah.
They should be smart enough to understand what you have explained to them. They should be smart enough to understand quickly, and they should have the ability to do quite an, right decision quickly. That is a kind of the bet to the complete.
It is different from person to person.
Yeah, reasonable time frame. If you go back and look at it among either your employees or your students. Some, if they are reading some, textbook or whatever literature, technical paper or something like that.
Yeah.
Some of them, they just briefly just scan through a paragraph, and then they quickly and correctly understand the content and meaning of that paragraph very, very quickly.
Very quick. Yeah. They're very quick, can understand everything. Yeah, that's
Yeah.
true.
Some, they need to read through 2 to 3 times to understand.
Yeah.
But others, they needed to repeat many, many times
Many
to
times. Yeah.
understand. Yeah.
Yeah. Yeah. It's about human capability. Yeah.
Yeah. It was, if they were misunderstood what they read, and then they misunderstood, and then they interpreted incorrectly. And then
Yeah.
they go and do the what with the misunderstanding, and then they need to repeat that, and do the remedial work for the whatever they have done.
Yeah.
Range of the
Yeah.
people, intelligence and understanding, how smart they are is there, very, very far apart. So that is where, fast learner, efficient and productive people and all that become, their level of the,
Yeah.
intelligent people become very far apart.
Yeah, I think training is important for some people. Yeah, some people they catch it very quickly. Some people it depends. Yeah,
Yeah.
but time management at the end is really important. Yeah.
Yeah, if we move to the time management, the person needs to know how to prioritize and how to manage, his available time. But priority is neither the one which is more important nor
Yeah.
the one which is urgent.
Yeah.
If I give you an example,
Yeah.
if I have a 10 text, I got to deliver to the 10 client in one particular day.
Yeah.
What I will do is I will quickly complete the 5 easy texts, which is not complex,
Yeah.
and then deliver to the 5 client.
Some people they start with the complex. Yeah.
Yeah, immediately, so that I reduce my, some of the text already, number of text I reduce, so that I won't receive a reminder call from
From the 10
my
people.
client, 5
Yeah.
clients. So I already reduced from 10 clients to 5 clients. I complete the 5 texts. Then I move on to the a little bit more difficult one, maybe 3 or 4 texts to complete and deliver again.
It's a very clever idea. Yeah, very clever.
Yeah. Only after that, I will pick up the most difficult one, which may be requiring longer duration, more attentions and all that. And then I complete that one without any more pressure, because I only need to do only this work only. I already deliver 9 works. But some other people, even in the middle management level, those people who work for me, some of them I have come across, they did very differently, and then started with the most important and most complex text,
which take time. Yeah.
Yeah, and then struggle with that single test for entire day, and then they never finish the work.
Which
So
complete complication from the client. Yeah.
yeah, eventually they receive the call from the 10 clients because they never finish and any single test within the 10 texts. So some people they wrongly manage their time, and then they wrongly prioritize. That is an important approach.
Yeah, I think it's really important. Yeah, I think it's really great example. I think, Professor. Yeah, I think I like it. Yeah.
For me, being I'm working for the boat industry, I divided my time into the 3 segments for every day. One prior to the office hour, another during the office hour, and then the last one after the office hour.
Yeah.
Actually, I am the early rider. I used to wake up very, very early, since from my high school, I wake up at 4 a.m.
Wow, that's very early.
4 a.m. So if I did not manage to wake up early, I feel myself I born for that day very late to catch up
That's
with the day-to-day life. That is the way I feel. So I used to wake up in the 4 a.m.
woke up early is the key.
Yeah. And then I get to the office 7 a.m. because I want to be ahead of other people. So I get to the office 7 a.m. So that I have been like that for many, many years. As a researcher, so I read the research paper and the literatures in the morning until 9 a.m. to catch up with the development. During the office hour, I don't do it any other works. I just emphasize on my business, the work in my business. After the office hour is my production time. That is the time I started writing technical paper, started drafting the chapter for the books I'm publishing.
Yeah.
Sometimes I went for evening teaching. So that is the way I manage.
I think this is really great way. The great way to manage time, Professor. Professor, if I can ask you a question that's related to your education and your before you start your experience. Professor, you did your MSc in hydrogeology, and in one of the top university in the world, which is in London. And after that, you did your PhD in geotechnical engineering. So if I can ask a very important question, why you choose hydrogeology, and why after that you did your PhD in geotechnic? Why geotechnic and why hydro? It's two questions in one. So please take me through the story about that and your journey about your decision. It's really important decision in that many students think about it. Why hydrogeology? Why geotechnic? Please, Professor, take me about this decision.
Yeah. So when I start my career, I started my career as an engineering geologist in the irrigation department in my home country, that is Burma. So
Yeah.
I work in the groundwater exploration project, or some sort of granted by the United Nations.
Yeah.
So groundwater is very important for the developing country because they need that groundwater, for either drinking water or for irrigations and all that. So I become a hydrogeologist, engineering geologist as well as a hydrogeologist.
Yeah.
And then, hydrogeology is actually study of the subsurface water, terms as, or groundwater, subsurface water, terms as groundwater.
It's a very important topic, yeah.
Yeah, this groundwater, it could be a source for the surface water as well, because many rivers and streams, they gain their water resources from the gaining from the groundwater as well.
Yeah.
So as I mentioned, groundwater is important for the developing country as a drinking water. At the same time, for the developed and industrialized country, they need to manage the groundwater because it is a carrier. It carries the contaminants along the pathway and then contaminated the receptor. So that's why groundwater is very important both for the developing country and
it's very important,
developed country. So I was lucky enough to be in the developing country to help in the groundwater exploration, and then also I managed to practice very good contaminant hydrogeology in United Kingdom, or to investigate the contaminated ground or to remediate the contaminated ground. So that is where I became a hydrogeologist. To answer your question, second question, as I mentioned, I was originally geologist who worked in the civil engineering industry as an engineering geologist and hydrogeologist. As I would say, fortunate and successful profession, I happened to climb up the ladder and then require managing many civil engineers in the well-organized big organization. So
Yeah.
there's many, of my staff that they are civil engineers.
Civil engineers. Yeah.
So if I speak frankly, there's some disadvantage of geologists, practicing and leading the civil engineering teams.
This is the one of
Yeah.
the issues.
So
Yeah.
I feel myself I need to also understand where and civil engineering.
Yeah.
That is why in my mid-career, I try myself to proceed my further study part-time doing the doctoral research in civil engineering and specializing
In
in
geotechnic.
geotechnics.
Yeah. Yeah. This is
So
the decision how it comes. Yeah.
yeah, at the time I was, working in the kind of big consulting company and government-owned company in Singapore, and then also leading the geotechnical department. Yeah,
Yeah.
with my experience in engineering, geology, and hydrogeology.
Yeah.
So basically, I try to equip myself to be a stronger leader in the civil engineering. That is why I try to complete my civil engineering as well.
And you are a very good geologist and civil engineer, Professor. Professor, I would like you are specialized. One of your specialty is the observational method. So I would like to ask a little bit about the observation method. Observation method, if I can make some introduction, observation method is part of geotechnical risk management. We use observation instrument to check the groundwater level. Also, we use the instrument to check the settlement, deflections, heave. But can you take me through the factor that could affect the data analysis that result from the observation method and mainly the instrument, and how this can be improved in your opinion, your experience? I appreciate it is very long topic, but of course, and there are many things that could be added, but we need to take an overview about it.
Yeah. And in the geotechnical instrumentation, there's still many challenges there. If we talk about instruments and monitoring data, many different kinds of challenge.
Yeah.
The very first one is a very simple accuracy and precision of the instrument. One is how accurately and precisely you need to measure. Whether there is an instrument which can measure, accurately, is there any method of measurement which can produce you a good degree of precise measurement? Those are the one of the challenges. And another one is the range of the measurement. So the ground, they are either stressed by the embankment field or either other infrastructure look on top of the ground. This stress can be go very far if the the land reclamation like very large area field, the stresses can go up to the infinity like that, very very deep depth.
Very deep. Yeah.
So you need a range of the measurements with the or require for the different type of instrument.
Yeah.
So you need to know what are the range of the measurement you are expecting to measure.
Yeah.
Also, you need to measure the procurement with a suitable range of the measuring capacity. But the higher the or magnitude of the measurement, the lesser will be the accuracy. But you need to make a judgment between that, or you meet both accuracy and range.
Yeah, we need to justify why it's really important. All of this process needs to be justified. Yeah.
There's also factor affecting the measurements. Some of them are environmental factor like temperature, atmosphere pressure, and all that. Some even affected by the method or instrument you apply, method or installation you use. That could affect your measurement as well. There's some human errors are there. Last few are the some kind of decision making for where and which step you need to be installed. That is also very critical, very important. So, and then how many you will be installed, and then how you should be distributed, and all that are also you need to consider depending upon the or ground profile, groundwater profile, and the geometry of your underlying soil, thickness, those variations you need to consider. After you have installed, you need to determine what are the suitable frequency of the measurements. And then after installing, after you have monitored and collected the data, you need to know how to utilize collected data. To improve these things, you need to improve the understanding and scale of the instrumentation engineer. Unfortunately, there is no school teaching instrumentation subject as a one subject in any kind of geotechnical courses.
Surprising,
almost none. So they need to be trained on the job training.
It needs to be taught in the industry. Not in the university, unfortunately.
So I hope my answer.
That's really good, Professor. It's really give an overview about the factor that's really affecting. Professor, I would like, after we discuss the factor, I would like to discuss a little bit about the future of the observation method from your experience. How do you see the future of the observation method? What type of technology we still need to improve in the observation method in this chapter of geotechnical engineering? I know it depends from person to person, but you've done a great job in observation method from different projects around the world. So it's really important to ask you. So how do you see the question could be answered?
If you look at from about 40 years ago, we are already in the future. So now that future is already current. So basically, automatic real-time monitoring is still the way to go. It has been implementing since 3 to 4 decades ago. But nowadays, it is better with new generation instrument. There's a many kind of instrument, many types of instrument developed, such as vibrating wire. I think that developed a bit long ago, fiber optics, etc. And then also, instrumentation industry has developed many kinds of data management software to manage the collected data, they process and manage the collected data. So with that, automated real-time monitoring become more efficient and more effective. Another thing is that, most instrument, what they are measuring is just the magnitude and rate of the, parameter. But those really does not, in many cases, give clear picture of what magnitude or what rate are danger for the failure. They don't give clearly. So interpretation after the data processing and decision making is always required. That is where a link between the data acquisitions, data processing, analyzing, interpretations, and
the whole process.
Most importantly, setting up the suitable alert and trigger level. To save the infrastructure from failure, and then to make a right decision, those are become essential.
It's really important,
Many software now they develop, they try to link these to be able to trigger the alert level, trigger level, and all that. Many software, they try to do it nowadays. But at this point, with the development of the AI, you need the AI aided software
to involve in this.
That will be fill up the required gap more closely.
That's great, Professor. That's great answer, to be honest. Professor, I would like to dive in some of the case study that you have involved. Professor, you have involved in writing a book called Geotechnical Instrument in Geotechnical Engineering. This is one of the greatest book. And you have one of the chapter was related to discussing different case study in reclamation. And one of the project was Changi project, Changi reclamation project based in Singapore. It's a really interesting project, to be honest. So if I can ask a question, and you have involved in this, and there are a lot of observation and method. So if I can start asking, what lesson could be learned from this project, and what mistake can be avoided in the future from your experience? It's really important. Each project we can learn something from. Thank you, Professor.
We did learn many things from the Changi East Reclamation Project in Singapore. These projects were, very big mega projects carried out under the several overlapping phases over a period of slightly more than a decade, so more than 10 years. In addition, it was carried out using the relatively new ground improvement technology in that day to improve the both underlying soil and reclamation field material. And then also we apply observation methods quite extensively using at that time was relatively new electronic and geotechnical instrument. So in that project, because of the scale of the project and the duration of the project, very, very big scale, we started using the automated real-time monitoring system to collect and manage the instrumentation data. And not only that, that location is a kind of remote location in the open and foreshore area. So we use the solar energy, and then also to transmit the those collected instrumentation data, we transmitted through the telecommunication system. At the time, using the cell phone modems and all that. Those are very, very early. It was in early, I think middle of 1990s. Around 1994, 1995, something like that. So we started using that, and then that was very beneficial to us. We managed
very clever way,
managed it about three decades ago. And then during that project, and the Myint project is, some sort of using the new technologies and all that, and then big scale. So we carry out the research and experimented tests. A lot of experimented tests were carried out that were required to implement such a new technology and learn and implement basics. So because of that, we managed to implement and complete the work very successfully. I think overall, we managed to complete the work not even in time, even ahead of the time we completed. And
that's it was very successful.
And then fine product, I think you may not believe. During that 1 decade period or that we managed to document as many as more than 100 over technical papers, and then I even have written 3 textbooks learning from those projects.
Wow, that's really a lot. So, that's really great.
And then many of the PhD students from Nanyang Technological University, and then a few from National University of Singapore, they attached to our project, and then I think we produced as many as about 10 PhD students. I think some of them even came from the abroad, like or
Yeah.
Norway, technical
Yeah.
university and all that. So
Many
one,
PhD students they graduate from this
yeah,
project. Yeah.
graduated from this project. And then also we produce many skillful and talented engineers.
That's really
And
interesting.
then those, documented literatures are nowadays very, very valuable and useful for the future generation.
I think so. I think
Yeah. Nevertheless, we did encounter some kind of minor failure there happened within the reclamation area. There is a tailing points happen to be there in the foreshore area underwater. So there was some sort of underwater failure during the filling of that tailing point, and because we did not fully understand the very different nature of the atrocious soil and the tailing material contained in the containment pan as a former sand mine tailing waste. So there was a failure there. However, we managed to overcome with the ground improvement method using the prefabricated vertical tray with a special consideration for atrocious soil. And those were well documented in the few technical papers, and also in one of my book called Compressibility of the Atrocious Soil, and we well documented.
It's well-known book.
Left as a references for the future generation.
It's a very it's very well known book, and you have discussed a lot of things about ground improvement. I will come to the ground improvement, but I would like to speak about the reclamation because you've done a lot of work on the reclamation, Professor. I would like to speak about the risk and the reclamation, Professor, if you allow to me. One of the main challenges in the reclamation is the flooding. So from your experience, Professor, how do you see this risk can be mitigated? I know there are many ways, but for the reclamation and flooding, how this risk can be mitigated from your experience, if you can take me through. Thank you very much.
Yeah, flooding and the reclamation project mainly come from the some sort of settlement magnitude, which is usually larger than what you have predicted. Another one is because of the sea level rise due to the global climate change, global warming, and all that, and then you underestimate that magnitude of the sea level rise. So from there, you could experience a flooding. Some of the examples, like you may know, Kansai International Airport in Japan, and that was built on the reclaimed land. So that land settled many meters more than the predicted settlement.
It was high,
mainly due to the underestimation of the settlement from the underlying very stiff to hard alluvial formation. So normally, geotechnical engineer, they do not consider improving those very stiff, deep-seated, formation, because they consider their compressibility is low. And then another one is
the ground profile, misunderstanding the ground profile.
They are deep-seated formation, so stress, inducing there will be not significant. So because of that, they don't normally improve, but happen, significant magnitude of settlement came from there. So also to improve that kind of very stiff, deep-seated formation, it is not economical to or practical to improve, to minimize the settlement, applying the existing available ground improvement methods. I did visit Kansai International Airport in 1999 with the Professor Kim from the South Korea. At the time, who was a vice president of the International Society of Soil Mechanics and Geotechnical Engineering.
Yeah,
And then
very well known. Yeah.
Myself and few others who attended the Yokohama conference company that tour, and then we visited. After that visit, I published a paper in the Maritime and Port Engineering Journal, some kind of advising paper, the use of the buried concrete white structure. In terms of effective density, that will be the much lower than the conventional engineer field. So that will be only effectively only slightly heavier than water. So that means almost no load. So if you mix with those concrete white structure with the engineering fee, you can minimize the additional load so that you can reduce the sediment. So a very simple approach.
Proposed, yeah.
Yeah. So from the we can minimize the sediment from the deep-seated compressible layer. That is one of the solutions suitable for that type of particular project. That is my advice paper. I published it, and maybe somewhere around in 2000, something like that.
Yeah.
Since from then, more than 3 decades ago, when we designed the land reclamation finish level, we did allow for the sea level rise. We designed the or over height to allow for the sea level rise, which is going to happen due to the global warming. So we allow in our sediment calculation. It was needed to be designed that way in those days.
I see.
Thank you.
Thank you, Professor. This is really a comprehensive answer for this, and you give a very good example about this case study. Professor, I would like to ask a question that related to the future of the observation method, if you allowed me. There are many new technology coming now to the market, and you can see that by yourself. One of the technology, for example, the satellite monitoring system. For the Shanji reclamation project, they have used 7,000 instruments. Correct me if I'm wrong, of course, the number. So in terms of course, they use it for a good way, of course, and very important reason. In terms of data quality and cost, do you think that InSight instrument will be irreplaceable in the future by other kind of technology, or it is not, from your experience? Thank you, Professor.
My answer is, to me, in situ instruments are unreplaceable. I will tell you the reason.
Yeah, please.
If you look at the ground performance, many of the changes and measurements and require not just on the surface. Many of them were happening within the soil mass at the different depth. They need to measure in the soil mass at several different depths within the soil mass. Those are kind of pore pressure in the soil mass, sediment at the various formation at the depth, lateral displacement, and earth pressure in the different formation at the depths.
Yeah.
Those cannot be measured from the space or from the distance. These geotechnical instruments needed to be in contact with the soil mass, within the soil mass.
That's fair enough.
Therefore, I believe those are not replaceable.
Yeah.
Even though some of the measurements, like measuring the sediment on the surface and either on the top of the ground and all that, could be measured from the satellite or from the distance, accuracy become questionable.
That's fair enough, Professor. I think that's answered a very issue that many researchers they keep asking it. Yeah, but I think this is fair enough. Professor, I would like to ask a question that related to the research, and you are a researcher and you have worked a lot of experience in your site, so you have worked in the on-site and the research. Based on your experience, what do you think the research that need to be highlighted, mainly in ground improvement and in hydrogeology, and you have high experience in both? Thank you very much.
Yeah. I think for hydrogeology, I would suggest major research needed to be emphasized in hydrogeology is that stay, impact of groundwater resources due to the global climate change and sea level rise. And then also, change of the, of pollutions, migration, and also groundwater flooding and all that due to the global climate change and sea level rise, etc. Those are the important research. And some of them they already started. I think that needs to be keep on going. For the geotechnical engineering and ground improvement, as you know, geotechnical engineering is a very young engineering subject.
Yeah.
Stay in the stage of development. Many of the findings we have done in the past and nowadays are very, very new and then developed within the last 50 years or so. We need a lot of research to develop this subject.
I think so. Yeah.
In ground improvement, important research like sustainable use of the natural material and also sustainable reuse of the waste in the ground improvement, such as reusing construction waste, as a replacement of the some natural aggregate, and then some suitable industrial waste which can be used as a binder. Those research are those are still needed to be, those type of research are still needed to be keep on going. And other research like environmentally friendly methods to improve the ground, sustainable use of the material for ground improvement, which can, also minimize the carbon footprints and all that. Those will be beneficial to the human being.
I think so. This is really...
There's also a significant area of research required in geotechnical instrumentation as well. Also in the observation and method especially. Currently, most research in geotechnical instrumentation are concentrated on the products rather than the process. Many new developments are on the products. So there have been, a lot of new geotechnical instrumentation using the different technology and then different kind of discipline, either fiber optics or electronics or hydraulics.
Kind of new technologies,
So many they have developed. However, research on the performance monitoring and assessment are lacking behind. Many engineers do not really clear what to do with the data they collected.
How to save it, how to process it. It's really a big topic now, data management.
To be able to use collected data more effectively and beneficially, suitable methods of performance assessment for each type of instrument and then each type of the discipline like other slope stability or settlement, those are required. The last one I would say is the application of the artificial intelligence in geotechnical instrumentation, which I briefly described in my latest geotechnical instrumentation book I published last year. Those are such as cloud computing, application of the artificial neural network and the monitoring, etc. Those are required to be developed. I hope I answer your question.
Answer very well. Thank you, Professor. Professor, I would like to, because you have a high experience in education, so it's worth to speak a little bit about the challenges in the education system. These days, we hear a lot about artificial intelligence, and artificial intelligence is booming now. It goes solution, but also challenges. One of the challenges is the plagiarism. Could you please elaborate on the challenges of the AI in the education system, and what is your proposed solution could be, and some of these issues or challenges from your perspective, from your opinion? Thank you, Professor.
Yeah. Before going into the challenges and solutions and all that,
Yeah.
firstly, I should explain briefly about the benefit from the AI into our geotechnical engineering and also in the publication area. One significant one is the machine-generated literature survey.
Yeah.
So in the past, when we want to do the literature survey, we got to go to the library and then read a lot of technical papers, such a lot of technical paper, textbook, and all that, and then do the literature survey manually. But with the machine-generated technical and literature survey, instead of doing literature survey manually, machine can very quickly summarize the existing available literatures in the area you want to survey. I did use machine-generated literature survey software provided by my publisher to prepare my, or literature survey session of my latest book, which was published in last year. Very effective. And then I saved a lot of time. It will save a lot of time for others and researchers as well. So they can be, very, very
helpful.
efficient.
Yeah, it's very easy to capture the information. Yeah, that's true. Yeah.
However, in general, there's some limitations there.
Yeah.
Those are, how to prevent crossing the copyright boundary.
Yeah, this is the issue.
Yeah. What is the extent your machine can reach?
Yeah, that's true.
Most importantly, how ethic is your machine? And machines like people, they need to be ethical.
True.
How well your machine has been trained to minimize algorithmic bias and fairness between the, interpreting and, kind of literature survey. Most important one, I will go back to the one I have mentioned previously in my this interview. How smart and intelligent is your machine?
Yeah.
They are smarter than yourself, or they are less smarter than yourself. I have come across some cases, machine misunderstood by the people and interpreted incorrectly as well. In some cases, therefore, I got to go back and read the original paper to clarify it.
Yeah.
Therefore, I would say it is very clear that human employees still required in this AI application.
So we need always to come back to the paper and read sometimes to interpret by ourselves. Yeah, it's really important. Yeah.
So if we go back to the plagiarism, yes, it is a big issue in the publication area and copyright area, as well as in our education as well. It has been known, plagiarism has been increased approximately 50% after AI has been developed. It is a big concern. There is a growing concern of using AI and chatbots to write an essay, coursework, even dissertation and thesis, etc. They are considered as a form of plagiarism. So to prevent such kind of abuse, there have been some AI software such as plagiarism detection tools. It can compare a given text against a vast volume of the text to identify similarity, etc., and then expose the plagiarism.
That could be one of the solutions. Yeah.
Eventually, I think a good set of robust regulation may be required to manage and developing the AI. and their applications. So AI itself needs to be checked for their ethics scale.
Yeah.
And then nowadays, there's some agency started, or providing the service of checking the, AI ethics and then issuing a certification, something like that. That have been started, but it needs to be, it needs to be practiced very widespreadly. I hope I answer your questions.
Yeah, Professor, this really gives a very comprehensive answer for my question, and really thank you for your contribution. But I would like to ask a question that I would like to ask it to many people, which is, with all of this experience and great experience, what is your advice for the patient who are interested in geotechnical engineering, in geologists, and who want to involve in this part? You have a great experience, so what is your advice, Professor?
Yeah, if I got to advise to become a good geotechnical engineer, first you need to look for a good school, good tertiary institution, and good geotechnical or engineering geology program of the field you are going to study. That you have to start with.
Yeah.
And then, not finished. After the graduation, you still need to look for a job in the organization where good on-the-job training programs are available for the engineering geologist or geotechnical engineer. And then you got to look for the organization where you can find experienced mentor in their mentoring group. So because geotechnical engineering, many things you need to learn on the job training. Just do not look for a good paymaster. Don't go and look for the organization, they pay well and all that. It will automatically come when you are really well trained to be a geotechnical engineer and then gain valuable experience.
Yeah.
That money will come automatically. You don't look for it, you look for the good mentor. And then also you join relevant professional organization where you can be benefited from the continuous professional development. That is also very important. And then keep in touch with the development, with the continuous planning approach through the either on the job training, or you should also go to the further study to earn the either further degree or further certification, something like that. And then also keep in touch and then try to plan through this structurally designed courses. Those are suitable for the
very important,
our kind of professional. Yeah. Either people always thought they are already late to study. I will give you, some suggestion. There is no such thing like it is too late to study. Myself, I left my country to practice internationally only at 38 years old. Yeah, in the big area only I left. And then I proceeded my PhD while I was working, and I completed my PhD only in 48 years old.
That's amazing.
Yeah. But I worked harder than and faster than other people to catch up with the professional in my age and my level. I believe I did. Yeah. Thank you very much.
It's a proof.
Yeah.
Thank you, Professor. It's a proof that it's never too late to go to the university. It's never too late to go to study. Professor, you are amazing. You have amazing achievement, amazing contribution, and you did a lot of work, and you teach us a lot. Thank you, Professor, for your contribution today, and thank you for your ad and your experience and with DEALITT. And please, thank you everyone who watching us today in DEALITT podcast. And please leave your comment and your question, and hopefully we'll come back to you. Thank you very much.
Thank you very much, Dr.